Hello all, this is the fifth lecture in files. So in this lecture we will see what is binary file and we will see fwrite and fread functions. So binary files. So binary files we have already seen what is a text file. So we will be storing characters. So in binary files instead of storing data in plain text format, they store it in the binary form. Binary form means we have only zeros and ones in the file, and we can it will be actually ASCII codes that will be stored. If you, even if you are trying to store some text and all, it will be stored in ASCII code. So it will be in binary format. They are stored in binary form and can hold a higher amount of data and not readable easily, and provides better security because it cannot be directly read by a person who, while opening that file. Okay, so that's the use of this binary file. And previously I have mentioned that binary file there won't be EOF, that is end of file will not be denoted. So there is no end of file in binary file. So you have to make sure that you have to make sure whenever you read, you have to make sure that there should be an end to that file and all. There is no EOF command to check whether the end of file has reached or not. So we'll see fwrite and fread operations. So writing to a binary file, we can use this fwrite function. So fwrite, this is a syntax fwrite, and we have four parameters here. One is address data, then the second is size of that data, and numbers data, how many number of data is there, and the pointer to file also, which file should be written, which onto which file we have to write this data. So address of data to be written in the disk. So the address data means it is the address of data to be written on the disk. So which data should be written. So we have to specify the address of that data as the first argument. Then second one is size data, size of data to be written in the disk. So how much size it should be there. So if you are including a structure, so if you want to write a structure into that file, so we have to specify the size of that structure that should be written. Okay, there is no end of file. That is why we have to specify the size also. Then the third one is number of such type of data. How many such type of data should be written? If we are writing only a single structure, we will be saying it is one. So if you have more than one, then you have to specify that numbers data. And the fourth argument is the pointer to the file where you want to write. So which file you want to write this thing. So these are the four arguments: fwrite, address data, so address of data to be written, then the size of the data. We have to specify the size also. We should address doesn't mean that we should not specify the size. We have to specify that size, how much data that should be written, and also how many such kind of data should be written, and also the pointer to that file. Similarly, we have fread function to read a binary file. So fread, the same four things: address data, size data, numbers data, and pointer to that file. The same four fields we have to use for fread function also. Okay, so we will see an example. So vim file 9.c. So this is an example. Here I have declared a structure. So I have declared a structure 3num. The name of the structure is 3num, and I have three numbers inside the structure: n1, n2, n3. Now I am declaring a structure variable num for this structure. So if I want to access n1, I have to use num.n1. If I want to access this one, num.n2, num.n3, like that, I can access the three members of this structure. So totally I require 4 plus 4 plus 4, 12 bytes of memory will be required for this. Then I am declaring a file pointer here. Now I am opening a file. You can name it anything. Since it is binary, I have made it as .bin file, sample.bin. And you have to, I have already mentioned, if it is text file, you will be using W. Since it is binary file, you have to replace W by WB. If it is read, you have to make it RB. If it is A, you have to make it as AB. If it is uh, R plus you can change it to R plus B, and W plus can be changed to W plus B, or A plus can be changed to A plus B. Okay, so W, you are writing binary, so this indicates that you are opening this file in binary mode. Okay, so you are checking whether it is null. If it is null, you can exit the program. If it is not null, you will be repeating this loop for n equal to 1, n less than 5. You will be repeating this loop 5 times. Sorry, 1, 2, 3, 4 times. N less than 5 means it will be repeating 4 times. This loop will be repeated 4 times. So now what you are doing is you are assigning first n1. 1 will be assigned to a number not n1. Number n2 will be 5 into 1, and number n3 will be 5 into 1 plus 1 will be done. And after doing all these operations, what you are doing is you are writing all these three values onto a file, the sample.bin file. So for that, you have to specify the first argument is the address of the data to be written. So the data that should be written is num. Num is a structure. So you have to specify the address of that structure. Sorry. So you have to specify the address of that structure first to write. Then you have to specify the second argument is the size. Size means you have to specify the size of the data that should be written. So you can use the size of function to find the size of the structure, because every system will have different number of bytes that will be used for integer. Since this is 64-bit system, you will be having the size will be 12 bytes. In some other system, it will be to 6 bytes. So here it will be 12 bytes that will be used. So size of struct.3num, struct3num. Then the another argument is 1. 1 means how many such data type. We are writing only one. So we are writing only this one data into that, and which file we have to write. So it should be written to this file sample.bin, which is pointed by fptr. So fptr. Then we are closing that file. So this will be repeated 4 times. When n becomes 2, we will calculate that value, and all those 3 values will be written. Then the third thing, everything will be written into that file. Okay. After writing everything into that file, now we will be closing that file here using fclose fptr. Now again we are opening that file fptr sample bin is opened using read mode. So since it is binary, we have to specify RB. We are checking whether it is null. If it is null, we will print this error and exit. If it is not null, what we are doing is we are repeating this loop 4 times. So we will be reading that from using fread from that file. The 4 arguments are address is num, then size of that thing, then 1 and fptr. Instead of write, we are specifying read. So we will be reading the first element. Then what we have to do is we are printing this. We are printing this into terminal. We are reading that file and we are printing it to the terminal. So n1 equal to percentage %d, n2 equal to percentage, like that, 3 numbers. So what we are printing is num.n1. So whatever it is there in the file will be read and it will be displayed in the terminal. Num.1, num.2, num.3. Then again n becomes 2, and again we will read the second set of inputs from the file, and it will be displayed. And after finally we are closing it, fclose of fptr. So we will be closing that file. So this is how we can read and write a binary file. Okay, so we will run this program, gcc file9.c. Now dot slash a dot out. So you can see that all the things. So n1 equal to 1, 5, 6. So this is the first time the loop repeats. Then the second thing that was written is 2. N becomes 2. Then 2 into 5, 10. 2 into 5, 10 plus 1, 11 will be written. Then n3, 3 into 3, it will be, 3 into 5, it will be 15. And 3 into 15 plus 1 will be written. So it will be read back from the file and it will be written to the terminal using this printf statement. Okay. So that's about fread and fwrite. Now we will see what's the difference between sequential and random access file. Sequential file means data is kept in sequential order. So you'll be reading one after the other. The first element will be read from the file, first record or the first character, then the second character, third character, like that we will be reading, or the first byte will be read. So if we want to read the last record of the file, we need to read all records before that record. So if we have 10 records stored in a file, and if we are reading we want to read the 10th record, so what happens is we have to read first, second, third, like that. When it reaches 10th, then you have to read. So it will be slower. So it takes more time if it's a sequential file. So sequential file means it will start from the starting location and it will traverse from first to second, like that it will be traversing. So it is known as sequential file. Then we have random access files where data can be read and modified randomly. So if we want to get the sixth record, we can directly get the sixth record. And if we want to modify the sixth record, we can modify it. So those type of files are known as random access files. So if we want to read the last record, we can read it directly here. So it takes less time when compared to this sequential file. So that's the difference between sequential file and random access file. So all the text files we have seen as sequential file. Now how to perform this random access in files? So for that we have three functions: fseek, ftell and rewind. Fseek, ftell function and rewind function. So we'll see these three functions. Fseek. So fseek, it is used for seeking the pointer position in the file at the specified position. So seek means we can seek the file pointer. So usually it will be reading one after the other. So if you want to change the position of that pointer to some location, we can use this function and change the location of that file pointer to that particular location, so that we can read from it or write into that file pointer, file location. So syntax is fseek file pointer. Now we have to specify the displacement and also the pointer position. So we will see what is this file pointer, displacement and pointer position. So file pointer, it is a pointer which points to the file. So we have to specify the which file we have to open, or from which file we have to seek, or which file, in which file we have to change the position. So for that we have to specify the file pointer. Then the displacement is the it can be positive or negative. Maybe it is a long int number that should be specified, long integer number. Okay, long int number. Displacement is a long int number. It can be positive or negative. It may be minus 10. We can specify plus 10 or simply 10 or 5, or sometimes minus 2 can be specified. So displacement can be positive or negative. This is the number of bytes which are skipped backward if negative. So if we say minus 5 from backward, so from the last position it will be skipped 5 bytes. Okay, it will be skipped minus 5. So if we say that displacement is minus 5, this is the number of bytes which are skipped backward if negative. If it is positive, it will be skipped forward from the current position. So if the file position is currently at second position, and if you specify plus 5, means it will skip the first 5 positions. It will skip the first 5 positions and it will take the 8th pointer. It will go to the 8th pointer. Okay. If it is negative and if it is at the last position, it will come backwards. From back, it will be skipping. Okay. Then we will attach L because this is a long integer. So displacement should be minus 5L or 10L or 21L or minus 22L. Like that, you have to specify the displacement. Then pointer position, it sets a pointer position in the file. So this file pointer will be pointing to the particular file, and in order to make this displacement, we have to check for this pointer position, whether this pointer position is at the starting, middle or end of the file. So based on this pointer position only, it will be taking this displacement. Okay. So that is why we are writing. So this negative or positive should be taken from the pointer position. It sets the pointer position in the file. So pointer position can be at 3 types. So secant, it denotes end of the file. Secant, if you are specifying secant, when the pointer is at the end of the file. If it is seek set, it denotes the starting of the file. And if it is seek current, it denotes the file's pointer's current position. So we can have only these 3 arguments here. Okay. So for this pointer position can be either secant, seekset, or seeker. So secant means it denotes the end of the point. So that is a file point is pointing to the last byte. Okay. Seek set means it is pointing to the starting of the file. Seek current means it will be denoting the file pointer's current position itself will be seek current. Okay. So these are some examples. So fseek p comma t. P means the file pointer. It is opening that file. It is seeking that file pointer. Here displacement is 10L and it is seek set. Seek set means it is at the starting position. So from starting position it has to skip 10 displacements, 10 characters or 10 bytes should be slipped. 10L means 10 bytes. So from 11th, so it will point to the 11th position. It will be pointing. So means pointer position is on beginning of the file. From this statement, pointer position is skipped 10 bytes from the beginning of the file. Okay. Now if it is fseek p fl seek current means, if we are giving a seek current means current position of the point position should be taken. Pointer position is the current position of the file, and from this statement pointer position is skipped 5 bytes forward. So current position may be at the middle, maybe 5th byte. So from that 5th byte you have to skip again 5. So you have to advance 5. 5 plus 5 after 10 bytes what is there, it will be taking that position. Then fseek we can have negative numbers also, minus fl and secant. So secant means the current position is at the end of the file. Now from minus 5 means from the last position we have to take skip minus 5 bytes. So means pointer position is at the end. From the end 5 bytes are to be skipped. Okay. So we have two other functions also, ftell and fwrite. So we will see example for this fseek, then you will understand. So ftell and fwrite is there. Ftell means it will return the value of the current pointer position in the file. Ftell function. Then syntax is we have to simply specify ftell and the file pointer should be specified. Then you can see the what is the current pointer position inside the file. Inside the file there will be a pointer that will be moving. So you can find the current address or the current pointer where it is located. Then we have rewind function to rewind to a particular location. So it is used to move the file pointer to the beginning of the given file. So syntax is rewind file pointer. So this file pointer may be at different position in the file. So if you want to go to the initial starting position, beginning of the file, you simply use this rewind file pointer. It will go to the starting position. They're like this. So if the file pointer it is here, if we apply this rewind of file pointer, then it will directly go to the starting position. The file point will point to this location. So this is the whole file. Okay, these are the records in it. Now we will see an example. Vim file 10.c. So here stdio.h. Now we have a file here, file star fp. Now character ch is used. Now int n is declared. Now we are opening a file in read mode, file1.c. It is already there. That file1.c is already there. So if we see in this example, file1. So file1.c. So we are trying to open an existing file. Okay. So file1.c, it is this file here. So this is a file1.c file. You can see this is a file1.c. So we are trying to open this file in read mode. So this is a C file that is being opened here. So file1.c. Now we will check whether that file is existing or not. If it is not existing, we can stop it. A file cannot be opened. Then if you want, you can use that exit statement. If you are using that exit statement, you have to use stdlive.h here. So if it is not null, then what you are doing is enter value of n to read n last. That is, you have an n characters. So you have to specify the number of characters. That is the displacement. So here n means the displacement. So you are scanning, you are getting that displacement from the user. So you can enter -5 or 5, anything you can enter. So here we are using this fseek function. and here it should point, what it points is, it is pointing to the file1.c. Now the file pointer, inside that the pointer is at the end, secant. Secant means it is at the end, and from the end we have to use skip minus n. Minus n means from the backward side, from we have to skip minus n. Okay, we have to skip minus n means if we are entering 5, it will skip minus 5 from the back. Secant is means it is at the pointer is at the back, so it will skip minus 5 bytes. And what it does is, while ch equal to get c of fp of not end of file, it will be returning, we will be printing one by one, so we will be printing that characters. So from the this position, from the after skipping minus 5, so if it may be in the 20th, let's imagine that it is in the 20th byte. So from 20th byte, it will be printing till the end of file, or one by character, one by one, it will be printing onto the terminal, and after that we are closing. Okay, so we will see an example. So gcc file 10.c. Now, if you compile it, you will be asked to enter the displacement value. So you have to enter that displacement value. So from the end, how many characters should be skipped? So I am going to skip 40 characters from the end. Okay, from 40 characters from the end. So if we see this, after skipping 40 characters, so this is the 40th character. From the end, 40 characters will be skipped. So these are the 40 characters from the end, 40 characters, and this will be the file pointer position. That is, it will be at the f close line of f1. So if you see this thing, I'll open that file, then you can see. So file1.c. So file1.c. So this is file1.c. So this is the 40th byte. So this is the 40th byte. So from the end, fseek, it is at the end. Pointer is at the end of the file. Now from end file, it will be skipping minus 25. I have given 25. So minus 25 means minus 25. It will be positioning to the this pointer. So it will be positioning to this f, and from this f, it will print one by one until it reaches the end of file. So that is what is run here. From this f, it is printing one by one, fc, like that it will be printing one by one until it reaches the end of file. So end of file is the last column here, so that will be printed here. Okay, so you can see this program once again. So in this program, what we are doing is, so we are reading that displacement value. If we are entering 25, so from end it will be skipping minus 25. Okay, now you can give other values also. So what we have seen is, so we have already seen we can have other values also, like f seek set also, from starting also you can skip. Okay, so we will check with that thing. I will change this value. Instead of I'll be specifying n, and instead of end, what you can give is seek set can be given. Okay, seek set means it will be from starting end. Okay, so caps set and starting. So if I enter n, from the starting position, those will be skipped, and until it reaches the end of file, each characters will be read. So if you run this program, so gcc file 10.c. Now I'll run this program. So you have to enter n characters. So I am entering simply 5 characters. So it will be skipping the first 5 characters. It will be skipping the first 5 characters, and the rest of the elements will be read. So from the after this 5 characters means inc, a hash inc will be excluded. After that, incl, hash incl will be included, and after that ude, from ude it will be printing, all the things will be printed. So using this fseek, you can go to a particular position. Okay, Why this here I am using this slash t, that is why this tab, the output is there is some space between these characters. So if you are not using that tab, then all the characters will be printed like this. So I'll be remove this. So if you print this now, I will compile it and I will run it again. Number of characters. So I will print 5. So everything will be printed as such. So what I have done is except the 5 characters. So I and C will be removed. So pointer will be positioned here until the end of the find. Everything will be printed. Okay. Now I will run it again. Now I will skip 25 characters. If I enter 25 characters, the first 25 characters will be script. So if first 25 means hash include stdio is gone, it is reading from ude stdlive.h. Now if I skip 100 characters, so the first 100 characters will be skipped. So it will be positioned from O. 100 characters means open. From here it will be printed. Okay. So this way you can enter. So this is how to use seek. So this is meant by random accessing. You can randomly access any position. So this is F set. So you can use FCUR also. That is usually used in different programs. If you want to go to the current position and all, you can go to that current position, and from that current position you can make this displacement. Okay. Now if I want to what I will do is I will try to make it as minus n, so that you can see this output once again. Made is the minus n. Now I am again compiling it, and again I am running it. Now I am skipping 200 characters or 200 characters. So if I skip 200 characters, minus n means so 200 characters. So it is reading everything. Let me check it out. Okay. Last 10 characters. So I am just skipping some 125. Let it be 125. So what happens is there is some error in this file 125. There is some problem with that 125 character. It should be written. Oh, sorry. I have to change the position also. Seek set. So I have to make it as seek end. Then only that will work. Okay. Seek end. So I have made it minus end, and I have to change this also. I have to make it as seek end. Okay, seek end. So it will be at the end of the file, and from end of file you have to make minus n. If you are giving 100, it will be from end of file minus 100 will be skipped. So if I compile it again and run it again, and I am going to specify 200 characters. Let it be 200 characters. So what happens is from the end of the file, it will go backwards. So 200 character will be from this braces. From this brackets, and from this bracket it will be reading. So from the end it will be minus 200 means it will reach here, and from there you will be reading this one character by character. You will be outputting output one by one, and when it reaches the end file it will come out. So this way you can randomly access bytes. So that's fseek, and F we have seen ftell. So it can find the current position. So also rewind will go back to the first file. So if we issue a rewind function, it will go back to the initial file. So that's all. Thank you.